when you're talking about this clinical trial, we've done several clinical trials, but the trial that we opened at the NCI right before, or right around the time I was leaving, was based on this hypermethylation that you heard about, that the SDH deficient GIST have global hypermethylation. Let me just back up a little bit and say that what methylation in general, when you methylate a gene, it turns it off. So it silences, so it affects a lot of genes. And we don't know, hundreds. And we don't know if 1 or 5 are critical, but it affects a lot of genes. And there's a drug, a class of drugs called DNA methyltransferase inhibitors. And they, when you treat patients, they tend, with that drug, they tend to cause demethylation of the genome. And this type of drug, this class of drug has been used for many years now in myeloproliferative disorders. These are pre-leukemias, and even in some leukemias. And they have, so we know they're relatively safe to give. We know how to give them. And they have very important benefits in myeloproliferative disorders. And so we were able to get access to a more potent DNA methyltransferase inhibitor. And we thought that would be a good drug to see if we could change the methylation of the genome, that might have a beneficial effect in patients with SDH deficient GIST. So the problem with the study is, one, it's only open at NIH, and it's given IV. You can't take it as a pill. So you have to spend 5 days at the NIH, or probably a little bit more. And so patients have been, it's been hard to recruit patients to the study because a lot of patients don't want to travel halfway across the country and then have to spend a week at the NIH. We're hoping to open that study in other centers as well. And you've heard that we're trying to open it in the UK as well. So that's probably the study. And Katie, I don't know if you have other, but let me just, the second question was related to cell line. Yeah. And so I think what the reason is nothing's been published yet. But Dr. Siklik is talking tomorrow or this afternoon. We're going to go over. He thinks he has, or he's told us he has, these SDH mutant GIST cell lines, the cells growing in culture. And one of the things that maybe you understood or maybe you didn't was that one of the problems we've had in developing new treatments is we haven't been able to study these tumors in a dish in the laboratory because we have not been able to grow these cells successfully. So we're all excited because if he's figured out how to do that, it will give us some tools to begin to study and look for new drugs that may have activity.
I have a question on that. When you say the drug therapy is only at NIH and it's 5 days or whatever, is that for one of the specific SDH, ABC?
No. So just to try to, and I know this is all so complicated.
Right.
But every one of the SDH alterations, be it a mutation or an epimutation, a genetic alteration, they all lead to altered methylation of the entire genome.
Okay.
We know that. And so right now, we don't know. It may be that the epimutant could respond better. It may be that the mutants, we don't know that. So we've not restricted it for any SDH deficient GIST.
What is the name of that drug?
It's called guadicitabine. And it's a first cousin. The only difference between that and the drug decitabine that's commercially available is it lasts a little bit longer. It has a slightly better half-life, so we think that makes it a little easier to give. And it's in clinical trial in those same myeloproliferative disorders, so it's been given to a lot of patients already.
Lee, what's the age of eligibility for the trial?
Is it 15?
15 and above, yeah.
And the thought is that drug would turn on.
Yeah. So
Explain that.
I don't want to.
no, so backtracking and trying to answer.
Yeah.
The first thing related to the question about Dr. Siklik's cell lines. in typical clinical trial work, what we all, I think, would love to be able to tell you is, listen, we have these cell lines that have exactly the same features that the tumors have. We have them in the petri dish or in a mouse. We treated them with the drug. The drug was really effective. Here are the data, hence we're opening a clinical trial. We don't have that. We have clinical leads, and we have the real evidence produced by Keith Killian that these genomes are highly, highly methylated. And we are talking, it was very well highlighted by Ruth, they are methylated globally, but in the case of SDHC promoter methylation, there is like an area of very hot hypermethylation, if you wish. So in one or the other situation, it is our hypothesis, and again, hypothesis, that a demethylating agent would be able to alter this peculiar pattern of methylation and potentially allow for a better functioning of the SDH in general machinery. We do not know if this is true. Every clinical trial is done to answer a question. If we had the answer already, we would not run a clinical trial. And in this particular case, we don't have as compelling clinical data, preclinical data, as we could have it in other situations because of the lack of models. Did I answer? Okay.
Could I excuse me, do you have anybody that is the wild type involved in that study? And could you share with us what's happening with them?
Yes? No.
Well, we have 3 patients so far in NIH, and we don't have the data. I think it's too early to share the data publicly. And third patient was only recruited about a few weeks ago.
Correct.
So I think we need to be careful about. Other thing about godocytidine is it's a prodrug, meaning it's a drug which is actually inactive in your hand. It's activated in the liver. So we need to be careful about how the liver handles the drug as well. And the problem we have with godocytidine is we have inherited the schedule of the drug administration from the leukemia guys, myelodysplastic guys, which is daily for 5 days. What we don't know is it the right schedule for GIST patients? So there are lots of question marks. The hypothesis is a fantastic hypothesis. If you demethylate the genome, that means you allow the genes to express. That means the protein will function. So that's a simple hypothesis. We don't have an animal or a in vitro, like a cell line data to back it up. So we're going with almost like one eye blind kind of thing. But it's a good hypothesis. We don't have anything else. We want to go for it. And if it works, and if we can prove it works, that's the first step in understanding the SDH treatment paradigm for the future. Other thing what we're looking at is it's not a GIST specific trial, which I think recently closed in Royal Marsden. We were looking at godocytidine followed by one of the newer immunotherapy drugs, pembrolizumab. But that's for all solid tumors, but not GIST specific. Meaning that if you use your demethylating agent first, you allow the genes to express, and that also expresses some of the tumor radicals as well. Then you come in with an immunotherapy drug. That trial has kind of recruited, and we are waiting for the data. And there are a couple of GIST patients in the trial. Very interesting to know actually what happens.
I just wanted to elaborate very quickly just to further explain. So the SDH mutated tumour is not the epimutation tumours. When we say that they cause global methylation and affect gene expression, the genes we were talking about mostly are tumour suppressor genes, so genes that would normally prevent us from developing tumours. So when we get hypermethylation because of the SDH mutations, you can switch off the tumour suppressor genes, or the genes that protect us from developing tumours. So the idea of giving a demethylating agent to somebody with an SDH mutation means that you might switch back on the tumour suppressor gene. And then for the patients with the SDHC epimutation, where it's very focal, where the methylation is affecting the expression of the SDHC gene, the idea might be for those patients, because they don't have a fixed mutation, they can be, their abnormality in the SDHC gene could be switched back on. So by giving them a demethylating agent, you could switch back on that gene and make their enzyme complex function properly again. I hope that makes sense.